6, product and quotient rule. So, we know a lot of the basic derivatives. We don't have everything yet, but we'll gather more as we go through this year, this unit. But we have a lot. We're going to focus on product and quotient rules. Product rule is to be used when you have two pieces, two terms or two factors that you can each take the derivative of, and they're multiplied together. Okay, so the idea is the product rule gives us a way to do that, because we can't just say, oh, hey, there's an x squared, let me take the derivative of that. Oh, hey, there's a sine x, let me take the derivative of that. We have a rule we have to use, and that is called the product rule. Okay, now, product rule. If a function is the product of two differentiable functions, then the derivative is, and there's multiple different ways we can put it, the first times the derivative of the second plus the second times the derivative of the first. Or, if we put it in symbols, if you're trying to take the derivative of f times g, then they're saying keep the first, take the derivative of the second, plus, and now we're going to switch it, keep the second, take the derivative of the first. Or they put it as f prime times g plus f times g prime. And I think this is just the reverses of above, isn't it? Yeah, so derivative of the first times the second plus the first times the derivative of the second. In other words, when you have a pair of items, they both have derivatives and they're being multiplied, take the derivative of one, keep the other. And then it's an adding, and then you're going to switch it. Okay? Are you guys okay with looking at either of these explanations here? If the x's are too much, I mean, we could break it down and say if h is f times g, then h prime could be f prime times g plus f times g prime. So it's derivative of the first plus, times the second plus the first times derivative of the second. Or you could say h prime is f times g prime plus f prime times g. It doesn't matter which you take the derivative of first, you just have to take the derivative of both. Now, let's look at these. F of x equals 2x minus 1 times x minus 4. Our job is to find the derivative. Well, I'll be honest. My brain says it wants to FOIL. However, FOILing would be the option of what we would have to do before today, because we wouldn't know the derivative, the product rule. Today we're learning a product rule. So, I'm going to say, let's use the product rule. I'll be honest, both are good. Either can work. What, the product rule here?
Yeah.
I don't know. FOILing and then the derivative, I don't know. Okay, so I'm going to write f prime of x. And I'm going to teach you how I usually think of it as, which is I usually start with the derivative of the first times the second. So notice we have two things being multiplied together here, right? 2x minus 1 times x minus 4. What's the derivative of 2x minus 1?
2.
2. So derivative of the first, keep the second. Are you okay?
Yeah,
Okay.
I just did it backwards.
Okay, plus, and now I'm going to keep the other one. So I'm going to keep 2x minus 1 times the derivative of the other one. So derivative of the second is 1. Okay? So clean it up. So if I distribute 2x minus 8 plus 2x minus 1, and if I clean it up, I'm at 4x minus 9?
Yep.
Okay. Either you said you did the. Did you do the derivative order reverse? Is that what you did?
2x minus 1 times 1 plus 4 or plus x minus 4 times 2.
Yeah. And it doesn't matter which order in this case. Okay. Now, if you had FOILed it out and then took the derivative, would you get the same result? You should. Okay. Y is a trinomial times a binomial. So derivative of one, keep the other, plus, and then we're going to flip it. So derivative of x squared plus 3x minus 1 is
2x plus 3.
okay. And I'm going to keep the other, 2x squared minus 5. And then don't forget it is a plus sign. And now I'm going to keep the other. Whoops. So I'm keeping my first of x squared plus 3x minus 1. And what's the derivative of 2x squared minus 5? 4x.
Do we FOIL now or do we do it again?
We're not being asked to do the derivative again. We're only being asked for first derivative. So
That is a thing.
that is a thing. We're going to learn that, honestly, this lesson, I think.
Oh, really?
Yeah. We learned that like the last page of this lesson.
Right.
Okay, so yes, we're going to clean this up then. So foiling. So I have 4x cubed minus 10x plus 6x squared minus 15, and then I'm going to distribute 4x cubed plus 12x squared minus 4x. Then clean up like terms. See if I agree with my own answer key here. I do. 8x cubed plus 18x squared minus 14x minus 15. Okay, so we're getting some of the basics, right? Okay, continuing along. Notice the next one. Y equals 2 sine x cosine x. Do we have a product going on here?
Yep.
We do. Okay, we're looking at a product, and here's the deal. The 2 is a constant. The 2 doesn't matter. But I see sine x times cosine x. So I'm going to kind of, in my brain, I like to break that up into 2 sine x times cosine x. So if we start with derivative of 2 sine x, what is the derivative of 2 sine x? 2 cosine x, because the derivative of sine is cosine, times, we're going to keep the other cosine x, plus. Now this time, I'm keeping 2 sine x times, what's the derivative of cosine x? Negative sine x. Clean up, of course. 2 cosine x times cosine x is 2 sine x times negative sine x.
Negative 2 so squared.
Yeah, so my right is minus 2 sine squared x. If you wanted to, you could factor out GCF of 2, but there's no requirement to do that. And at this level, I know you guys can recognize it is equivalent if there was a 2 factored out. Okay, ready for D? And the key is going to be recognizing these product rule problems once we get out of every rule is a product problem. Okay, so right here, we see a product happening. G of x is 3e to the x minus x squared times x cubed minus 1. So, derivative of the first.
3e to the x minus 2x.
Okay. Derivative of 3e to the x is 3e to the x minus derivative of x squared is 2x times, I'm going to keep the x cubed minus 1 as it is. Product rule says it's plus. Now I'm going to keep the 3e to the x minus x squared and derivative of x cubed minus 1.
3x squared.
3x squared. Now, I have written in my notes an either or scenario. As we start foiling this back together, is this going to be pretty? No. I have in my notes for that reason, you could leave this answer as is. Because here's the deal. We can foil it back together, but there's going to be very minimal cleanup. I mean, you're going to foil it back together, you're going to have like 6 terms, and I think only 1 term cleans up. So if you want, we can just stop here. Okay? And it's just, the key is that e to the x in there. It just doesn't make things work nice. Okay? So we can leave it, if you're okay with that. Didn't figure you guys would complain about, you know,
Doing less.
doing less, yeah. Okay, now, a couple of things. Since multiplication and addition are both commutative, in other words, order doesn't matter, product rule is hard to mix up unless you misunderstand the rules. It's easy, take turn on the factors is the way they're saying. 1 derivative at a time for each term. Now, cautionary tale. Don't confuse product rule with limit properties. It's incorrect for the product rule. And this is what we can't do, is you can't say, oh, the derivative of f times g is f prime times g prime. That's the big no-no. Okay? And that's the easy thing until you guys get yourselves trained to do is, oh, okay, I'm just going to do take the derivative of each. If it's a product rule, you have to multiply them. Okay? You take turns. You got the basics there. Okay? Because now, we're going to move on. We're going to talk about quotient rule. Quotient rule is a little different in how we do it. I mean, similar idea, but there's some differences here. So quotient rule, obviously when you see something divided by something is when the quotient rule is going to come into play. If a function is the quotient of 2 differentiable functions, then the derivative is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared. Now, I feel like I say that different because I think I usually start with derivative of the top times the bottom minus the top times derivative of the bottom all over the bottom squared. If you are a mnemonic person, like where you like your mnemonic devices to help memorize things, low D high minus high D low over low low. I don't know, I can't think of her name, but she sings this. Oh, it's Verge, that's her name. She's a big calculus person, does some of the AP calculus videos, and she sings it. That's not me, but so that is something to think about.
I feel like I'll remember it, I just won't know what it means.
Yeah, so, well, the low D high is saying low is in the denominator. D high means derivative of the high, so derivative of the top.
Gotcha.
Minus high is the top times D low is derivative of the low. Does that help explain? The D is just indicating derivative.
Yeah.
It's saying derivative of what follows. Okay. Now, if I had to guess on A, if you tried to long divide that out, it's not going to work out. It's not going to be nice. So this is where the quotient rule does come into play. So, G prime of X. Order matters here, right? In terms of their subtraction on top. So I always start with derivative of the top times the denominator. Or you can just think the denominator times derivative of the top. But derivative of the top is
6x squared plus 8x.
okay, so that's derivative of the top times the denominator, x minus 5. And then what do you have to remember? It's quotient rule, so it is subtracting. And now you do the other two. So now it's, you keep the top, 2x cubed plus 4x squared minus 7 times derivative of the denominator. Derivative of x minus 5 is 1 all over denominator squared. So x minus 5 quantity squared. Okay. Now, numerator we usually try and clean up. Denominator, it's pretty usual to just leave it as is. Oh, so what's that mean? On top we're foiling? So if I FOIL on top, six x cubed minus 30x squared plus 8x squared minus 40x. Did you pay attention to that minus sign in the middle? That minus sign is going to have to distribute to everything, yes? So it's going to end up, and we're just multiplying by 1, so that's easy at least. So minus 2x cubed minus 4x squared plus 7. Please be in the habit of writing the denominator. It's so easy to forget to put it on if you try and do cleanup and then put it back on at the end. It's so easy to forget to put it back on. What?
I totally didn't not put the denominator for my second step.
I caution you against it. It is so easy to forget about it. Okay, do we have some cleanup on top?
4x cubed plus 4x squared. No. Minus 26x squared.
Did you keep going? 4x cubed minus 26x squared. Then you just had singletons, minus 40x and plus 7 over x minus 5 squared. Now, if you see a reason to square out the denominator, of course, square out the denominator, but I don't feel like there's usually a reason. Okay. G of x, e to the x over x squared plus 1. This is one you're going to have to use quotient rule on, because you can't divide that out, not with the e to the x up there. So, derivative of the top, derivative of e to the x is times the denominator, so times x squared plus 1, and then what? Minus derivative of the denominator, or keep the top, I guess is what I usually say, isn't it? And then derivative of the denominator, 2x over x squared plus 1 quantity squared. Now, before you go to clean up, I'm seeing something a little different here. Did you guys go ahead and distribute, or did you wait?
Yeah, sure.
Okay. If you distribute, you're just going to end up having to undo it, because what are all three terms going to have in common?
Mm-hmm.
They're all going to have e to the x. And so what I'm going to do is I'm going to go ahead and pull that e to the x GCF out front. Okay. So if you distribute, you just do the next step. And then what remains? What are my pieces that remain? There's an x squared, a plus 1, and a, what type of 2x? A minus 2x. Okay. So, and you could write it as x squared plus 1 minus 2x, or I'm actually going to make it x squared minus 2x plus 1 all over x squared plus 1 quantity squared. This would be a good way to leave it. Or, if you catch it, what else could that numerator do? Yeah, x squared minus 2x plus 1 factors into what times what? And I'm going to say or here, so it's not that you'd have to go to this step.
X squared.
What'd you say?
X squared plus 1. Is that what it is? No. X plus 1 squared.
Getting closer.
X minus 1 squared.
Oh, -2. I do need glasses.
Oh, because you don't know. Yeah, okay.
Yeah, it's blurry.
Okay, now, and what I have written in my notes, guys. This or this. They're both good. Okay? Being able to recognize that the first one can become that second one is good, even if you don't go there. Okay? Okay? I think we're going to keep going because I really want to practice some of these derivatives and the scenario. There's some other places I have that I think we will probably shortcut. So C, f of x equals natural log of x over x minus 2. Yeah, I'm glad this one we're going to have to practice some cleanup. So f prime of x. The derivative of the top, what's the derivative of natural log of x? Okay. Times the denominator, x minus 2. Quotient rule says to
Oh, you do E high low.
I do the derivative of the top times the denominator, is what I do.
Yeah.
Now, is that any different than doing the denominator times derivative of the top? Other than I'm just confusing you along the way.
Yeah.
But,
It's alright.
and you've seen it, I mean, it was listed both ways. So,
Yeah.
So now I'm doing the derivative of the top times the bottom minus, now I'm going to keep the top and derivative of the bottom. What's derivative of x minus 2? 1. All over x minus 2 quantity squared. Now let's clean this up and see where we're at. Fractions within fractions are not cool. So we need to be able to figure out a way to deal with that. But let's first distribute. 1 over x times x becomes 1 minus 1 over x times 2. Yuck. Minus natural log of x times 1. Minus natural log of x all over x minus 2 quantity squared. Now, This is where I'm going to say you don't usually want to leave a fraction within a fraction. What denominator do we need to get rid of?
X.
The x. So on top, I want to get rid of a denominator of x. I'm going to multiply by x. What you do to the top of a fraction, you do to the bottom of a fraction. So we're going to multiply the numerator and denominator by x. On top, distribute that x through.
Minus 2 minus natural log of x squared.
Not natural log of x squared, that's illegal. It's x times natural log of x. That x cannot just magically be put into a natural log of x. It's not a natural log. So it's separate. It's x natural log of x. So that's why you'll see I wrote x, ln x. Over x minus 2 quantity squared. Okay, so easy way to get rid of fractions within fractions there, right? X minus 2 minus x ln x over x minus 2 squared.
X minus 2 squared.
No, on the denominator.
Yeah.
Because it's denominator squared. The original denominator was x minus 2,
Yeah.
and then it's denominator times denominator.
Yeah.
So x minus 2 quantity squared.
Multiplied by x.
Oh yeah,
X out front. Okay. Okay.
you're right. I
so
totally was
confused.
not catching. I thought you were just like the whole
Yeah.
glasses list, squinting to see type
Yeah.
thing. And so I didn't understand what you were questioning. Yeah, there's an x that I left off.
Okay.
Okay, are we good? Okay. Let's see what fun tricks this one has. Y prime. Derivative of the top. What's derivative of sine of x?
Cosine of x.
Cosine of x. Times the denominator. So times 1 plus cosine x. Quotient rule says minus. Now it's keep the numerator, so keep sine x. Derivative of the denominator. Derivative of 1 plus cosine x.
Negative sine x.
Negative sine x. All over
1 plus cosine x. 1 x squared.
1 plus cosine x. Quantity squared. Okay, let's work on that top a little bit. In that first set of terms, cosine x can distribute. So cosine x times 1 is cosine x plus, what's cosine x times cosine x?
Cosine x squared.
How about cosine squared x? Okay, remember, there is a difference between cosine squared x and cosine x squared. Those are not the same. Because this is saying, this right here is saying it's cosine x quantity squared. Whereas this one is saying it's the cosine of x squared. Okay? So plus cosine squared x minus sine x times negative sine x is going to be plus sine squared x over 1 plus cosine x quantity squared.
This is cosine squared x plus sine squared x equal 1.
Cosine squared x plus sine squared x is a Pythagorean identity, and it does indeed equal 1.
With that being said, doesn't 1 plus cosine, oh, no. That'd be cosine squared x equals sine.
And then you can make it 1 over 1 plus cosine x, right? Or no?
I think so. Yeah, go one more step. That's why I was just double checking. I want to make sure I wasn't overlooking anything. With this, and that's the importance of catching that Pythagorean identity, yes? is that, oh, now we have a common factor top and bottom, so we can cancel that factor and now just have 1 over 1 plus cosine x. Okay. Big reminder, subtraction is not commutative like addition. You have to be careful with the quotient rule. The quotient rule is not just derivative of the top over derivative of the bottom. That's the mistake we'll make, you know, moving forward until you just get used to using it all the time. And then another fun mnemonic in here, I don't know that I've ever used this one or heard it, but derivative of high over ho is ho-de high minus high-de ho over ho-ho. So, okay. And all of these, they always say as long as the denominator does not equal 0, of course.
I do kind of like the high D low.
High D low minus low D high. What's in the top of the next page? What are we going to have to do on this one? Let's find an equation of the tangent line to the graph of f at 0, 1 for f of x equals cosine x over 1 minus sine x. We're going to find the derivative, yes. Okay, you're going to have the derivative in order to be able to write the equation. So we have our point. We know our point is xy. And then in order to talk about this, we're going to have to figure out what the derivative is. What is the derivative of cosine over 1 minus sine x? Is this too much? Hey, I'm looking at the clock and realizing we might not get through it after all.
Yeah.
Well.
Oops, it's gonna be like negative sine of x times 1 minus sine of x minus cosine of x would be negative cosine of x. All of this 1 minus sine of x.
Yep, you got it. It always takes me a moment to process when they throw an extra negative into a derivative of a cosine or sine. If I clean this up, negative sine x plus sine squared x plus cosine squared x over 1 minus sine x quantity squared. What do we know?
Get the 1 minus sine x or minus sine x plus
Yeah.
1.
You got a Pythagorean identity there. Sine squared plus cosine squared can go to 1. So 1 minus sine x is a good way to put it, because what's my denominator? It's 1 minus sine x squared, isn't it? And so just like the previous one, you can cancel a factor. And we'll leave it as 1 over 1 minus sine x. And tomorrow when we're starting class, you guys can work to get your equation of the tangent line. Okay?